So earlier we said that our conjecture is basically that 1 plus 2 plus 3 plus n all the way to n basically is n times n plus 1 divided by 2. And so in other terms what we were saying is basically if you want to know the sum 15, one way to get it is by multiplying the 5 with the 6 and dividing it all by 2. And so, if you test it out, this is 30 divided by 2, which is going to be 15, so it seems like it works. If I want to know what the number here is, all I have to do is look at my n is 3, and just multiply with the next guy and divide by 2. And so basically 12 divided by 2 is going to be at the end basically 6. So yeah, well, we would like to provide a proof, but I'm going to start with a simple proof that doesn't require induction. So in this case, I'm going to be pretty much listing the numbers that I'm counting, which is 1 plus 2 plus 3 plus so on and so forth, all the way to n. And I'm going to do it in a funny looking way. First, I'm going to do it with the order from smallest to largest. And I'm going to do the same thing again, but going in the opposite direction. So I'm going to put the 1 here, and then 2 here, and then 3 there, and so on and so forth, basically all the way up to n. Now, if you kind of think about it a little bit, it should kind of make a little bit more sense. So think of it like an elimination problem or like a substitution problem or one of those linear equations, and go ahead and just add both sides. So, s plus s is going to be 2 of them, 2 s's. And next we're supposed to be working on the 1 plus n, which is going to give us basically n plus 1. Okay, and the 2 is going to get added with the number underneath, but what is the number underneath? Really, in reality, the number underneath is technically n minus 1. That's the number that's supposed to be right there underneath it. It's the number that came before n. So again, if you add the 2 with the n plus 1, you will end up with n plus 1 one more time. And again, what about the 3? The 3 with the number underneath it, which would have been n minus 2, would be again n plus 1. So how many times is this going to happen? It's going to happen over and over and over again until the end. The last guy is also going to be n plus 1. And how many of these will we have? Well, we will have basically n of them, because that's how many started at the beginning, n times. So instead of writing it like n times n, n plus 1 time, and so on and so forth so many times, we could just write n plus 1 times the n times that we're kind of thinking of. But this gives us double what we want. So, what we want is going to be half of the amount. So the s that we're looking for, the amount that we're looking for, is n times n plus 1, all divided by 2. So that's kind of a proof that doesn't rely so much on induction, but you kind of have to visualize what's going on inside these ellipses. So what's going on here, what's going on there, and do you actually believe that there's n plus 1 terms, and so on and so forth. So it's not a very professional looking proof, but it's kind of, interesting, because at least you can see the motivation for why it works, and you can see in the next page the induction proof, and hopefully it'll make more sense.